So we're here today to talk through this challenging double Kakuro puzzle. We'll actually have more of these in the Art of Puzzles 2 sometime later this year, including many more from Serkan that are just as brilliant as this one. What I wanted to do today was at least showcase some of the different ways these larger cells affect constraints in this kind of puzzle, particularly where now the seeing of multiple cells or both cells in a sum really take effect. But first we have to do some of the easier break-ins in the puzzle, and one of the first that some solvers may catch is this 22 sum requires a 9 somewhere within it. Can't be in this box because it will affect the adjacent sum. 9 is too large to have a sum of 3 digits with 9 in it being 9. Similarly, 9 can't be here. Some of those won't work. And then recognizing the smaller and larger ends of the sum, you can also say that the remaining digits in the 22 sum will have a 5 or 6 down there and a 7 or 8 up here. The 5, 6 is then going to place a 1, 2, or 3 constraint into these cells. The 1 can't be in the top cell, and the sum as a whole needs to have a 1 in it. So most solvers with a lot of basic Kakuro experience would have this kind of deduction happen. And I find particularly in these double boxes it's useful when you have just a few possibilities to mark them out. And the reason is that whichever digit these are, it's clearing a lot of cells in the surrounding space. Particularly there's an interesting deduction that links this cell, which is a 7 or 8, with this sum, which is a 15. A 15 can be 6 and 9, or it can be 7 plus 8, but if this is 7 plus 8 in any order, the digit that will sit in the cell will also sit in one of these two cells, and that would be impossible. So this has to be a 6, 9, something that we haven't taken account of yet, but this puzzle has basically every little sort of sneaky deduction hidden into it. This column has 8 of 9 digits represented, total sum of 39, which means 6 is a digit that's absent from the 1 to 9 space. So this cell can't be a 6, it can't be a 7 or 8, it has to be a 9. Get that being a 6. I haven't marked it yet, but the next deduction I was able to make was that this cell can be no larger than a 3. It's actually the case with this cell now being a 9 that we see that this cell can be no larger than an 8, and it's actually going to be quite hard to get to a sum of 24. 24 with 3 leaves 21. 21 can be 6, 7, and 8. That's a maximum sum, particularly when we know we can't use a 9. So we can conclude that this is a 3. These cells are a 7 or 8. We actually can use this being a 3 to force the remaining cells here. Get a 6, get this being a 2, get this being an 8, this being a 7, and we get this being a 5. The remaining two elements of this sum are a 2 and a 3. If we actually go through and consider the possibilities to get this to actually be a complete sum, the larger digit has to be at the top. You can get that. And for now I'm going to sort of make my way up the right side of the top and show you a different kind of challenging deduction this puzzle holds. And it has to do with now two adjacent sums where these two cells have to add up to 9 more than whatever this sum is. A different way of saying that is if this large cell is a 4, 5, basically the minimum constraint applied by this tied to the maximum constraint for this sum working out, you have this kind of constraint. This cell can be an 8 or a 9. Consider what happens if this is a 9. If this is a 9, then these two cells above it add up to 5, as well as these two cells over here that add up to 5. This big cell is in common, which means that if this and this is 5, then these two cells are the same for this sum to also be 5 coming here. So critically, you can never have a digit leave behind two identical sums that are using a shared large cell. And so this 9 is eliminated. It must be an 8. That gives this 5. Of the remaining digits 1 and 2 here, the larger has to go to complete the larger side of the common sum. We can get this. We now actually have the ability to use these rows coming across much more effectively. At the start, you might have identified that the digits 1 and 3 don't happen in the second row. it has 7 cells used and a sum of 41 out of 45, so it's missing 4 total. What's less known is what is missing from the top here, but it's some x and some 10 minus x. What's interesting is actually that in this whole row, there are only 2 cells that are different, specifically this one here and that one there. The other 6 digits in these large cells will be used by both sums. So right now, there's some digit that sits here, there's some digit that sits there. You should be able to conclude that either a 1 or 3 is the missing digit that sits in this row. If not, there's no other place in the top sum that a 1 or 3 would occur, and then 1 and 3 would also be the missing digits here. Having recognized that 1 or 3 is missing, that means the other missing digit up top is a 7 or 9. We can't use that as quickly, perhaps, as the fact that these cells also have to be 6 in difference because of this. So if the top is a 1 or 3, the second one is a 7 or 9. What we can then start to do is actually try to place the digits in this top row, and we actually have a whole lot coming up this column. We have the 5, 9, 3, 8, 7. The 6 doesn't appear here, 4 doesn't appear here. This seems to have a choice of just 1 or 2 left for it. The 1 is not possible because of the exclusion in this row, so we can get a 2 there and actually fill out that right column. And now we have to go about placing the remaining large numbers in the space. We need a 5, we need a 6, we need an 8, and we need a 7 or a 9. We're not sure exactly which. Actually, we need both, but we don't know which goes here and which goes elsewhere. The smallest sum remaining is a 6 coming down. It's going to need to take the 5. The next digit we need to try to place is the 6. Again, the leftmost column, like the rightmost column, does not have a 6 in it. That's 39 using 8 cells. Notice if we place a 6 here, we get an 8 in this across clue with a 10, not possible. So the only place for a 6 is right in this cell. Gives us a 3. This sums to a 9. We can actually eliminate down here. And so the missing digits are 3 and 7 up top. The remaining things to place over here are 9 and 8. We have to ask ourselves which is used. And now we get to another kind of neat but interesting deduction, which is the 4 clue over here has to use exactly a 1 or a 3 in either of these spots, but that means collectively 1 and 3 aren't possible for this larger cell. So this has to be a 2, a 4, or something higher. It means that if this cell is a 6, that would force this cell to be either a 1 or a 3, which would cause an issue down here. That's not possible. So again, we get a case where a paired sum, both of whose cells see a larger gray clue, eliminate 2 digits from that, although we don't yet know how to specify the order of these digits. So this is some 2, 4, 2, 4 in unknown order. This is 9. We'll see that actually if this were 2, it would place another 9 here. So this is 4. Actually, the digits that were there didn't make sense. The 2, 4 was what I was trying to get at. This is a 7. The remaining digit up here is an 8. And we at least have worked across the right side and across the top. The next place to probably try to work is in the bottom corner. And that's going to be easiest, probably not by starting looking this way, but starting looking from this side. And I think this one, given right there, is quite critical. The reason is this 7 is normally a 1 plus 2 plus 4. In this cell, it has to be a 2 plus 4. The 19 that's coming down here needs to have a larger digit, a 2 or a 4, so this is a possible sum. If a 1 set down here would be 18 in 2 cells, you couldn't do it. So you can make this kind of entry. This cell, the 8 needs a 1 somewhere, and it's going to be one of those entries. And now what's even useful, having filled this corner, is to recognize this cell can be no larger than a 7. If this smaller entry were a 2, 2 and 7 leaves 10, you can't do it. So you actually can, from the right corner, this lower right corner, move to this side and get the 7 sum complete. we now should at least try to finish what the sum is. It's remaining in 15. The two choices are this being a 7 or 6. That leaves the top being an 8 or 9. If this is a 9, it's 2 plus 2. That's not going to work. So it's an 8. We get a 3. We get a 7. Carrying this to the top. We can finally direct the order of those two clues. The next step is to really figure out how to fill the remaining cells here, I guess. This is a 4 or 5. This is a 5 or 6. If this is a 6, it becomes a 7, which sees this cell all the way over there. So this is a 5. That's an 8. This is a 4. You get the one cell that sees into the middle of the heart, and this is more of a standard Kakuro to solve in the center, but we'll be able to get through it pretty quickly in comparison to the rest here. And we now have to finish out some of these entries, and I'm trying to see exactly what the easiest way to do this will be. I think one place that's helpful is to actually recognize that where I marked this as two cells being a 4, again, I have to remember this fact that this column doesn't have a 6 in it at all, so the 4 is required to be in the lower cell. We now get a case where this cell looks like it can be a 1, 3, or 5. Notice if it's a 1 or 3, it's going to pair with the 1, 3 here, add to 4, so we'll have a sum of 8 in these cells, leaving 11 over here. That's no good. So it needs to be the largest it can be, which is a 5. We're left with a 1, 3 and a 1, 3. In these cells, if this is a 3 over here, we get 12, sum of 7, 7 sees 7. That's not going to work, so it can actually force just one option. As so, this is a sum of 19, 4 left over. It's a 5. Only digit left in this column is a 2. Only digit left that can go in this bottom space is a 5. So we're done with the outside, and we can now think about the middle. The middle is a pretty classic case of largest and smallest sums working together. 24, most people recognize as 9 and 8 and 7. The thing it critically intersects is this 23 clue, which, if this is not the smallest possible, is going to leave too few digits for the rest. And even as we've done that, we're now left with just 1 to 4 as the options for the remaining cells in this column. Another place where you need to see that kind of effect is this is a very large sum missing the digits 1 and 3. This is intersecting a very small clue which needs a 1, 2, or 3. If this can't be a 1 or 3, it's left with one option. That actually means this cell here is left with one option. Coming all the way to this side, this 8's also pretty small. Now with these digits placed, it's left with one option. We have what looks to be a 1, 2, 1, 2. The 19 needs a large total sum, so this is the only thing that would make sense for it. We've placed this 1, it plays ping pong to the side and forces this group. Notice again in the center we have a constraint of 1, 2, 3, which we can use. Place the remaining digit. We now have a case where we have a new place that's going to cause a potentially total sum problem. That's because now these cells are all 6 or larger. If this is 6 and that's 8, the smallest remaining possible sum of these cells is 7. That would be 4 and 1 and 2. You'll see that all of these digits are forced by just taking the smallest possible that remain in each column, and the smallest possible in each of these cells adds up to 21. So that's forced. If I propagate out this 9, this 8, 9, somewhere like here, this now has just one digit available to it. This also now has just one digit available to it, and that finishes out the row. This would normally have a 32 with 24 taken would have a choice of 3 plus 5 or 2 plus 6. The 3's that are already in the space leave this to be 2 plus 6. It has to be this order. We now have 21 across, which has 6 taken, so it needs a remaining sum of 15. It could be 9 and 6, but the 9's are canceled in each of these cells, so it has to be 8 plus 7. And 8's over here, so this is 8 plus 7. We now see this as a single value cell because all the other numbers around it are used. becomes a 5. The remaining cell up here is a 5. This is also a single valued cell because all the other numbers around it are used. We now have a sum of 24 with 2 left. We get a 3 and a 1. And this is where in a puzzle championship I'd turn this in and lose points, but we'll fill the missing cell I forgot earlier. And we're through this challenging but hopefully enjoyable double Kakuro puzzle with a heart theme. Thanks for listening.